Hi, everybody. It is Sunday, September 4th, 2022. I am Disappointed Phillies fan. I am back from Elixir Conf, and it's time to record another Exercism exercise. Looking at the syllabus, looks like we can tackle date and times, and so we're going to do that today. Elixir Standard Library offers 4 different modules for working with dates and time, each with its own struct. The date module, a date struct can be created using the D sigil, sample here. Time module, time struct can be created using the T sigil, sample here. Naive datetime module for datetimes without a time zone, and a struct can be created with a sigil N. A datetime module is for datetimes with a time zone. Use this module for time zones other than UTC. Using this module for time zones other than UTC requires an external dependency, a time zone database, which is something usually will kind of just be there for your Phoenix apps and stuff, but that is technically open. You gotta kind of bring your own time zone database. But there's a good one, and there's actually another one which is more competitive. But anyway, that is not an introduction-based concern. What is an instruction-based concern is comparison. So to compare a date and time to one another, you're going to want to look for either the compare or the diff function. Technically, you can, the compiler will not complain if you use equals, greater than, or less than. And you may get some truthy responses, but ultimately, the way equality works, for that kind of operator, it's not going to be what you want. So you're going to want to compare a diff. As an example here, so if you had 2 datetime structs and you wanted to compare them, you could call datetime.compare, pass in value 1, pass in value 2, and then you'll either get back less than, equals, or greater than, and that'll kind of give you a hint as if they are equal. If you use diff, which is right down here, you can actually get a numerical reference for how far apart they are, based on a unit of time, which is kind of cool. One way you can kind of visually think of this is with kind of this kind of chart where you have a date value and a time value, and they are isolated, they are their own thing. And then a naive date time basically combines them both. And then a date time basically is the naive date time plus some time zone information, such as time zone, UTS offset, and so forth. This is actually part of a talk I did back in March 2020 called Working with Time Zones in an Elixir Phoenix app. I will link that in the description, should you ever want to check it out. But yeah, so that is a quick kind of summary of date and times, and today we're going to be working on the library fees example. So your librarian friend has asked you to extend her library software to automatically calculate late fees. Her current system stores the exact date and time of a book checked out as an ISO 8601 datetime string. She runs a local library in a small town in Ghana, which uses GMT time zones, doesn't use daylight savings time, and doesn't need to worry about other time zones. Oh, isn't that nice? All right, let's get moving here. I can close my blog. I don't think we'll be doing that, and we'll download our example. Apologies too. I know my lighting is really weird. That's because I am recording this at night. Normally I record during the day and get some nice window light, but it is nighttime, and if I turn that lamp on behind me, it's going to be a nuclear winter, so I've kind of adjusted my desk lighting to hopefully accommodate. Alright, so let us get this going. So that's going to be, this is going to be the test, and then this is going to be the readme. I haven't done this in a week, so I feel like I'm a little slow. Alright, let's look at step 1. Implement the datetime from string function. It should take an ISO 8601 datetime string as an argument and return a naive datetime struct. Okay. I believe there should be a function for that. Yeah, there you go. From ISO 1. Okay, that looks like what we want. What else does this say? Okay, so it should just return the one. All right, so we're going to use the bang version of this, which basically will say if it works, it works. If it doesn't, it'll throw, which typically you don't want to do, at least without giving it like forethought of like if you're in a supervision tree or something, which we haven't really talked about yet. But typically I'd be very wary of using bang unless you intentionally know what you're doing. Alright, so with that done, let's run at test at file, test at cursor, and let's see if this passes. Cool, so we got some passes. Looking good. Alright, number 2. Determine if a book was checked out before noon. If a book was checked out before noon, the reader has 28 days to return it. If it was checked out at or afternoon, it's 29 days. Implement before noon function. It should take and return a boolean. Okay. So a couple ways we could do this. Yeah, I mean, like one thing is I wonder if we could do that. So my thought initially is maybe we know it's incoming as a let me close this. I'll minimize that so we don't jump back and forth. We don't see that in the background. But one of my thoughts is to take the incoming datetime and then and then grab the time out of it, like in a case. So I always I don't know why I'm like not spelling that right, but we'll say to time, and then we can match. So we can match on a time struct, and then we can say hour, and we'll capture hour. And then we can say when hour is what are we looking for? Less than or equal to 12 is what I think the logic we're looking for. If it was checked out at or after noon, it's 29 days. If it was checked out before noon, so that would just be less than 12, will return true. Otherwise, we'll return false. Actually, no, we gotta do case. Yeah, that should be fine. And then this thing's gonna, what is this complaining about? Name time to times undefined or private. Oh, we gotta pass in an argument. That would help. The other thing you do here too, which is like, we've since we've learned about type specs, I feel like it's helpful to mention that like, if I were writing this in a production environment, like I would make it clear that like I'm accepting a naive datetime and I'm returning a boolean, just to get that kind of like dialyzer check going. Otherwise, you know, it's not clear, and even this value here doesn't really make it yeah, clear. Like the description here says it should take a naive. I keep saying naive datetime, and return a boolean. But I think it's good to make that explicit in the type spec. All right, let's see if before noon test pass. Those are looking good. All right, let's move on. Number 3. Calculate the return date based on the checkout date time. Calculate the return date, implement return date /1. It should take in a naive datetime struct and return a date struct, either 28 or 29 days later. Okay. Okay. So we can we'll do case, and if it's before noon, true. If it's true or false, I'd probably just do an if statement. If before, this is checked out date time, do else. So if it's before noon, what was it, 28? Then 29? Or no, we need to return a date struct. Okay. Let's take a look at the functions for date. Builds a new ISO date. New error. Add looks helpful. So okay, so this will take an incoming date, and then yeah, that looks good. So one of the things we want to do is we want to pull out the date time, or we want to pull out the date out of this. Yeah, so we want to use the toDate function. So we'll say we'll call this checkout date, and we'll say toDate, and we'll pass it in, and we'll do it up here so that way it's available for both of them. And then we'll say add, and this will add 28, and then this will add 29. All right, cool. Let's run the test, and we're going to validate return date, and that looks good. All right, cool. Moving on, number 4. Determine how late the return of the book was. The library has a flat rate for late returns. To be able to calculate the fee, we need to know how many days after the return date the book was actually returned. Implement days late argument count 2. I don't know how I'm saying that weird. It should take a date struct, the planned return date time, and a naive datetime struct, the actual return date time. Oh, I thought those 3 arguments there. If the actual return date is on an earlier or the same day as the planned return date time, the function should return 0. Otherwise, the function should return the difference between those 2 dates in days. The library checks both the date and time of the actual return of the book for statistical purposes, but doesn't use the time when calculating late fees. Okay, so given blah blah, let's do this. Alrighty, so it should take a date struct and the planned return date time and the actual return date time. If the actual return date is on an earlier or the same day as the planned return date time. Okay, so we need, so we'll say this is date, and we'll grab the date value out of that, and then we'll say date compare, right? If it's on an earlier or the same day, yeah, we want like an if, and that will be like greater than or less than. And this is the part that actually gets me a little confused usually. So if the plan date and return date else, if the actual return date is on or earlier, the function returns 0. Yeah, the thing of it is like date dot pair compares 2 date structs, returns GT if the first date is later than the second, and LT vice versa. Returns GT The first date is later than the second. So we're down here. Oh. If the first date is later than the second. So we're looking for if the actual return date is later than the second. I think that's what we want. This is the tests are definitely going to help us verify that Boolean logic. So if the actual return date is on an earlier or the same day, yeah, I think what we're going to end up doing is that'll be like less than. So that would just be, that would be return 0, and then this would be the actual like the difference in those 2 days. So like date dot diff maybe. Curious if this will work. Days late. Let's run these. Yeah, these fail. All right, some of them work. Days late return 0 when identical date time. When identical dates but different times. When planned return date is later than the actual return. So let's try that. And we're gonna run a cursor again. Alright, they all pass. Yeah, Boolean logic like that always gets me a little confused. I kind of wonder out loud here. If I'm looking at a date here, day. Yeah, you can't. I was going to say, like, I was wondering out loud if you could pattern match the date and time out of this type, but you can't do that. That's why you have to use the toDate function. Okay, that's fine. All right, moving right along. Let's work on number 5. Are we up to? All right, let's close this up. Days late. Yeah, that's what we just did. Okay, day 5. The library has a special offer for returning books on Mondays. Implement Monday ? Function. It should take a naive date time struct and return a Boolean. Okay. I wonder, Monday. Can you even get a Monday from this without a time zone? I guess you could. Oh, that's weird. I don't even know if I would ever think to do that. I think what we want to do is turn this into a date and then grab the day of the week. I think that's what we want. So we'll say toDate, and we'll pass in the date time, and then we'll do this as a pipe. Yeah, I don't know. We'll do it as a pipe. I might rewrite this later. So that'll turn into a date, and then you could say date, day of the week, and that'll return calendar.day of the week, which is, what is that type? Calendar.day of the week, non-negative integer. Okay. Day of the week. And then I guess you would say day of the week equals 1, Is that Monday? Everybody loves Mondays. Looks like that's Monday. So what is Monday? Monday is 1. Okay. Okay. Alright, let's number 6. Yeah, last one. Implement calculate late fees function. It should take 3 arguments to ISO datetime strings. Check out datetime, and the actual return datetime. And the late fee for 1 day, it should return the total late fee according to how late the actual return of the book was. Include the special Monday offer. If you return the book on Monday, your late fee is 50% off, rounded down. Okay. So I assume late fee would just be 0 if you did something else. So we'll say late fee equals so I guess you would do like days late, and you'd pass in planned return date, actual return date time. Now you see, and they use these words checkout, return, and rate like there's no time there. It's like kills me. I'm gonna write a spec just so I can keep track of that in my head. And this is gonna return a non-negative integer. Yeah, that sounds right. All right, so the first argument is it should take 3 arguments to ISO thing. So this first is a string, and then rate is the late fee for 1 day. It should return the total late fee. What format is late fee? That's an integer. Okay, so I guess that's like cents. All right, we'll say integer. We'll say non-negative integer to be even more explicit. Okay. So days late wants days late wants the planned return date, and then the actual return date time. So this one, planned return date would be you need the checkout time. Don't you? I mean, I know you need that, but like planned return date. What is checkout date time and the actual return date time? How do you figure out the planned return time if I have the checkout date time? Because it doesn't. Or no, we do. We get return date. Okay. Okay. All right. So that's going to be a return date, and that takes in a thing. So we'll say date time from string. I don't know if I like these this piping style here. Then the actual return date time is date time from string return. The reason I don't like this piping is because like it changes the structure. Like typically a good pipe, a better pipe in general is something that keeps is like when it's just transforming the same value type over and over again. I don't really love this, but I think it's fine for now. Okay. So then we just need to do if days late, and then we'll just give in the 2 else. So if days late Uh, can you? I was gonna say, can you capture? That might be excessive. Like, I don't know if I need to do that, but yeah, I'm just gonna do this up here. Days late. Let's see here. It should return the total late fee according to how late the actual return of the book was. Okay. If days late is greater than 0, do else. If it's not late, then it would just return 0, right? And if it is late, then we need the cost, right? Calculate late fee. Late fee. Calculate late fee, and that'll take. Oh well, this is we're building calculate late fee. ISO strings takes checkout date time, actual date time, and the fee. Okay, so that the rate is what we're looking for. Rate times and I'm gonna write this out the really long stupid way, and then we'll clean it up later. Rate time days late. We'll call this fee. We'll just call this late fee. And then we can do if Monday's Monday. Else. And then what we're passing into Monday, the planned return date, the actual return date time. Is that what Monday takes? Yeah, it takes the date time. So if it's Monday, it'll be late fee times 0.5. Is that 50% off? And you could put that as a module attribute or something. All right, let's run this, and hopefully it passes, and then we can just refactor it. All right, it did not pass. Why? Because we did not truncate it. Okay. Did you tell me to truncate it? I don't think you did. Round it down, you did tell me. Okay. Okay. Test a cursor. All right, that looks good. All right, so how do we clean this up? All right, well, one thing we can do to clean this up is discount rate. Discount Monday rate, and we'll say 0.50. And I think it's nice to have that up there, so it's more like configurable thing. And then the next thing we should do is planned return date. Date time from string, date time from string. I mean, I don't know. I don't really like these date time for string things, just like sitting here in the middle. It feels awkward that we even accept these here anyway, but feel like what I'd like to do is just straight up say checkout date time, and then immediately grab the checkout, and then we'll call this return date time. I don't like converting these two like in the middle. I just feel like, I don't know, that just feels a little weird. And then you can basically say the return date equals, then you could say actual. I guess you don't need to say actual there. You could just say return. So this basically does the conversion straight up, and then it figures out how many days late this is, and then it does some, questionable stuff. The Monday thing, this like nested if structure, one way you can usually handle that is with like a tuple. So like you could say something like this. Actually, I don't want to. You could say case, and you could say Monday, and it's just return date. This is a little long though. I don't really know if I like that. Days late. I'm just gonna do this. Days late. I want to capture them as their own thing, and then is Monday. I don't feel like. I'll just do it there. Because days late is longer, that's why I want to like. I don't like putting it inline there. But what you could do here is you could do case and you could capture. So like days late true when days late is greater than 0. And then you could say this would be rate or trunk. Yeah, I'll just put trunk for now. Trunk. Late fee times discount monthly rate. Or no, you need no, you need late fee there. Alright, I wanna back out of this a little bit. What is a clean way to do this? I mean, another way too is just to break this out into a private, like define p late fee, and then that would just take in days late and rate. No, you wouldn't even need the rate. When days late is greater than 0, do, and that would just be no, you do need the rate. We'll put days late times right just for the order. We'll keep them in order. And then define P late fee when return 0. 0.0? Probably. So that would give you the late fee. Then you would just need to figure out if the Monday, if it should be Monday. I mean, in with the goal of keeping this simple. Late fee, days late. Let's run these tests. Let's see if it still works. Doesn't work because we got a compiler error on line 53. No, I want to go back. Go back. 53. Okay. Return date. Checkout date time, return date. No, what does return date require? Just the checkout. Days late. Days late takes return date and the return time. Okay. Yeah, this still feels real clunky. Alright, let's try these again. Alright, so that just needs the trunk. One of the things you can do, which I don't even know if I don't really like this, but you could pipe the trunk right in there. And that'll probably work. Yeah, it does work. I don't really like that though. Alright, what do we want to do here? Calculate late fee. I mean, basically what you want to do is you want to get the late fee and then you want to potentially get the days late and then calculate the late fee, calculate the discount. Define P maybe discount late fee. So that'll take in days late and it'll take in the return date time, and then it'll be like if maybe discount late fee takes in the late fee, so it would be like if Monday late fee times. Otherwise, it'll just be the late fee. So you don't even need days late, you just need, or I'm sorry, you don't even need days late, you just need maybe discount. So in this one, days late, late fee. So given late day, days late, you would return. You'd figure out the late fee. You'd say, maybe discount late fee, given the return date time, and then you would trunk it, which I'd probably put in a wrapper or something, a domain one. Or sure. Let's run all the tests. Yeah, they all pass. Yeah, even trunk I would say, like define P, round down late fee. And that would just be do trunk late fee. I like doing that because round down speaks in the domain that we were given. So they explicitly ask for rounding down. So this is how the customer talks. And so if I can write code in the same language that the customer talks, I feel like it'll be better. All right. Is there anything here? Datetime from string. Yeah. If I could, I would rename that with a bang because I feel like I want to express that it can throw. Because that, yeah, they only, it said it has to return because they didn't really say if it returns. Yeah, they didn't say if it receives an invalid string. So I can't change that. All right, so this accepts checkout or return an array. It immediately grabs the date time of the checkout and the date time of the return, and then it calculates the days late by figuring out the return date and the return date time, and then based off days late, calculates the late fees, maybe discounts it, and then rounds it down. I'm okay. I'm fairly satisfied with that. If Monday, late fee. Yeah. I'm fine with that. I mean, this feels a little weird. I almost feel like I wish I could guard against that, and maybe I could write a guard. I don't think I could write a custom guard with that. You can write custom guards, but I don't think you can use just arbitrary functions for that. Def guard. Generate a mappable suitable for guard expressions. Yeah. Generates compile time with the definition aren't allowing guards. Yeah, we can't do that. I mean, you could figure out is Monday ahead of time, but why would you want to do that? You'd want to control. You'd want to contain the knowledge of when a discount should be applied, not arbitrarily require the caller to figure out if it's Monday or not. Then you're kind of leaking in the implementation. All right, I think this is good enough. Let's run this test one more time, and let us exercism. Submit. Exercism. Submit. Lib. Library fees. Boy. All right, let's bring this thing out. Exercism. I don't know why that's not working. Submit lib. Library fees. It's processing, and it passed. All right. All right. Let's take a peek at the community solutions. See if there's any excitement. Daytime less than 12. That seems reasonable. Checkout dates before noon. Did they write a before noon function? If before noon. Oh, they did. Was that part of it? One day. Yeah, before noon. I don't know, I'm losing it. If before noon. 2829. Diff max. Oh, that's interesting. Max. Floor. They did floor, not trunk. Round it down. I think trunk is what we want here. I mean, trunk would do everything, right? Trunk. 5.4 goes to 5. 5.99 goes to 5. Yeah, we want to round down. Yeah, I think that's what we would want. All right. 42 stars. Compare. Before noon. That's good. I mean, you can pull out the hour value, but I think I like that they did compare there. That's a little complex. Yeah, they did this is kind of like where I was headed for, where I was writing a case that had like a tuple that was, going to do different things. I don't know if that reads better. Days late fee. Yeah, you shouldn't, I don't like the idea of passing in an argument that says is Monday, because then you're leaking the concept that discounts are applied based off given day. I'd much rather just say maybe at discount and then do the logic if needed. But all right, I think I'm pretty happy with this. So we're gonna mark as complete, and we're gonna publish our solution. And we have learned date and times. Show me more concepts. Cool. Show me concepts. All right, cool. So that was date and time. Yeah, I don't know what we're gonna do next time, and maybe we'll finally get back into PIDs and processes, considering we skipped those for a while. And we're gonna start running in some locks again if we don't get through those. So yeah, maybe next time we'll do PIDs. Until then, I want to thank you all for watching, and if you have any questions or feedback, definitely let me know. Other than that, I will see you next time. Bye bye.